Hello my dear students, welcome back once again to the Science Explainer. I'm Rahul. Today I want to explain you one important concept that is known as ionization enthalpy. Why I'm explaining this? Because most of the student knew the definition and even they know the factors affecting the ionization enthalpy and how it varies in the periodic table. But in my video, I will explain it in a different way. Just be with the video and understand what is ionization enthalpy. First of all, when we talk about the ionization, it's a process of removal of the electron or addition of electron, because you want to create an ion here. Now right now there is a nucleus here which is positively charged, and now around that somewhere here the electron is revolving. Here is the electron, and between the nucleus and the electron there is a force of attraction, right? Now because of this force of attraction, the electron tries to revolve in a faster way. The reason? If it not moves in a faster way, the electron will fall into the nucleus. To avoid that, the electron is revolving around the nucleus in a high velocity. And it is balanced. This force is balanced by centrifugal force produced by the velocity of electron. Now, you have to supply a certain amount of energy to this electron. By that, the electron gains energy and its velocity gets increased, and because of that reason the centrifugal force, the force acting away from the center, increases and breaks the force of attraction between the nucleus and the electron, and by that the electron is removed off. Now this energy which is using to remove the electron from an atom is known as ionization enthalpy. Now ionization enthalpy, we can define the amount of energy required to remove electron from outermost shell of an isolated gaseous neutral atom. This is the definition for the ionization enthalpy. This is the amount of energy we are using to remove the electron from an isolated outermost shell of an isolated gaseous neutral atom. Now majority time we can say that this ionization enthalpy depends upon the nuclear force. Yes, we'll write here the factors affecting the ionization enthalpy. The first factor, we can say that the nuclear charge or nuclear force. Here the ionization enthalpy or the energy is increases as the force of attraction between the electron and the nucleus it is increased. Therefore the ionization enthalpy is directly proportional to nuclear force or nuclear charge. Second one, let's take one more atom here. This is a nucleus and somewhere here is an electron with a large distance. So let's take this is as R2 and this one is R1. Taking as R1 and R2, the R2 is very large. And from the Coulomb's law, we know that F is inversely proportional to 1 by R square. As the distance between the two charges increases, the force is drastically decreases. And therefore, we can say that if the distance between the electron and nucleus is increases, this electron experiences less attraction by the nucleus. And by that, you have a chance to remove this electron by using a very little amount of energy. And therefore, we can say that the ionization enthalpy is inversely proportional to the radius. Greater the radius, lesser will be the ionization enthalpy, that is atomic size. Now third factor, important factor. Now this electron is present at a far distance and experiencing less attraction. Now what I will do that I will place some more electrons in between the nucleus and the electron. Now these electrons are very crazy. These stops the force of attraction between the nucleus and the electron. They reduce, they screen, they shield the force of attraction between the nucleus and the electron, and by that this electron experiences less attraction. And you have a chance to remove that electron by using a less amount of energy. And therefore we can say that ionization enthalpy, let me clear it. In this case, more number of electrons are there. Now more screening effect or shielding effect. Then if more screening effect is there, this electron experience less attraction, and the electron which is less attracted by a nucleus, you can remove it very easily. Therefore low ionization energy. Very low ionization energy is needed. So therefore, ionization enthalpy, you can make a relation to low ionization enthalpy, more screening effect. Inverse relationship is there. Therefore, ionization enthalpy is inversely proportional to screening effect. Screening effect. Or you can call it the shielding effect also. Now, how it varies? Variation. The variation depends on only two factors. One is atomic size. Atomic size. The second one is the nuclear charge. Nuclear charge. Only these are the two factors which decides the ionization enthalpy, how it varies in a periodic table. Let's see. Now, in the first case, along the period, if you take along the period, the atomic size increases. Sorry, it's wrong. Along the period, you are adding the electron in a same shell, and because of that reason, what happens? The atom shrinks and atomic size decreases. Therefore, we can say that here the atomic size decreases along the period. Now, nuclear charge, you are moving along the period means you are increasing the proton numbers. The number of protons increase in a nucleus, and therefore the nuclear charge is also increased. As atomic size is small, ionization enthalpy should be large. If nuclear charge is large, the ionization enthalpy is large. These two factors makes increase in ionization energy along the group. Okay, along the period, not a period, not a group. It's a period, students. Now again, this is along the period, but again, first factor, that is atomic size is increases down the group. Second one, the nuclear charge, this is decreasing down the group because the shell numbers are increasing here. As many number of shells are there, the distance is increases, the nuclear force decreases over there. So therefore, what we can say that by both the methods here, the atomic size increases, more atomic size, less ionization enthalpy. Now, nuclear charge is less means the ionization enthalpy obviously less it is. So this makes decrease in ionization enthalpy along the or down the group. I will write down the group. Okay, now you may get the question. You may get a question. There is only 17 minutes. That what is ionization enthalpy, and what are the factors affecting the ionization enthalpy? Or you may get ionization enthalpy definition, or you have to write how it varies in a periodic table. Now this is all about, students. Thank you for watching this video.